Magandang araw mga bata! Welcome to Grade 10 Science Lesson. And I'm your teacher, your companion to your science adventure. So buckle up and get ready to power your mind. But before we start, kindly make sure that you have your Module 3 at hand as well as your notebook and pen. Today, we will focus on the processes and landforms along plate boundaries, and you are expected to explain the different processes that occur along plate boundaries. You have learned in our previous lesson that lithospheric are slowly moving at different directions. These movements of plates can be classified into three types of boundaries, namely convergent plate boundary, divergent plate boundary, and transform fault boundary. Along the plate margins, earthquakes, volcanoes, and mountain ridges are being formed. But what other geologic activities may be formed in the three types of plate boundaries? What will happen if two different lithospheric plates collide? Why do we need to study these different geologic processes? Let's find out in today's lesson. Remember that there are two types of crust: the continental crust, which is thicker but less dense, and the oceanic crust, which is thinner and denser. This idea about crust is very important to help you understand the geologic processes occurring along the plate boundaries. This time, we are going to understand Lesson 1 of your science module, the processes and landforms along with convergence of plates. Pages 5 to 7 of your module directed you to perform simulation activities. So I want you to perform activity number 1, 2, and 3. You can pause this video while you are doing the activity. Then if you're done, you can play it to continue. Are you ready? Are you ready? Your time starts now. Let's start with the convergent plate boundary. The geologic processes that will be formed along this type of boundary depends on the materials of plates that are colliding. We have convergence between oceanic and continental plate, between two oceanic crusts, between two continental crusts. The conduct of activity 1 on page 5 of your module simulated what happens when oceanic and continental plates converge. The foam that was half soaked in water represented the oceanic plates, while the foam that was not soaked in water represented the continental plates. As you push the two foams towards each other, or as they converge, the wet foam is forced down while the dry foam curves upward. Why did it happen? Can you tell? The wet foam, which represented the oceanic crust, is denser than the dry foam that represented the thicker but less dense continental crust. Remember, when an oceanic crust converges with a continental crust, a crack between the crusts underwater called trench is formed. Since the oceanic crust has greater mass due to the presence of water on it, so its density is also greater. The oceanic plate is forced down into the mantle. This process is called subduction. As the oceanic plate subducts, the leading edge of the subducting plates melts or becomes fluid, which turns into magma. Due to the heat in the mantle, the magma builds up a pressure that enables it to push the ground above it. The column of rising magma is called a mantle plume. When there is volcanic activity such as an eruption, the ground moves, and so an earthquake is felt. Because subduction continues, a group of volcanoes called volcanic arc is formed at the surface of the continental crust along the boundary where the two crusts converge. The movement of the ground may cause disturbance in the ocean. The water may flip or kick upwards to a few meters high. This is what we call tsunamis, a Japanese term for harbor wave. This event is very dangerous when it moves inland, destroying lives and properties. The convergence of these plates formed trenches, mountains, earthquakes, and volcanoes in the seafloor and on land. I hope the concept of convergence between the oceanic and continental crust was clear. On page 6 of your science module, activity number 2, you were directed to perform a simulation activity using two pieces of foams submerged in a tray with water. The submerged foams represented two oceanic plates. As you push the two submerged foams towards each other, you are simulating the convergence of the two oceanic plates. When a convergent boundary occurs between two oceanic plates, one of those plates will subduct beneath the other. Normally, the older plates will subduct because it's higher density. The subducting plate is heated as it falls deeper into the Earth's mantle. What will be the result from the convergence of two oceanic plates? Can you tell? The convergence of two oceanic plates will result to a zone of progressively deeper earthquakes, the occurrence of tsunamis, the formation of oceanic trench, a chain of volcanic island arc, or even the destructions of lithosphere. This explains why the Philippines is mostly loaded with volcanoes. The different islands were believed to have originated from the convergence of two oceanic crusts. Now going back to the simulation of activity on page 6, activity 3 of your science module, you were directed to use two crunchy crackers or two slices of bread, whose 1/3 of each piece is soaked with water. You were supposed to position them on a flat surface such as that soaked part touch each other. You were instructed to push them toward each other. In this activity, you are simulating the convergence of two continental plates. So, what happened when two continental plates collide? Convergence of two continental crusts or plates result in a collision zone which would cause shallow earthquakes. At that place, a crack called fault is formed. This type of convergence will cause no subduction since the two plates have the same densities. There will be no volcanoes formed, nor tsunamis. The convergence will result in a group of highlands forms that we call mountain ranges. Now let us check your understanding. Go to page 10 of your module and answer item 1 to 9 in what's more section of your module. You have 10 minutes to answer this. You did great! A pat on your shoulder for the job well done. Now, let's move on to the second part of our lesson, the processes and landforms along divergent plate boundary. Divergent plate boundary is when the lithosphere plates are moving from each other. If the divergent movement is happening in the oceanic plates, it can lead to the formation of oceanic ridges and rift valleys. But what are the oceanic ridge and rift valleys? How are they formed? Oceanic ridge is an underwater mountain range formed by plate tectonics. The oceanic ridge occurs when convection currents rise in the mantle beneath the oceanic crust and create magma where two tectonic plates meet a divergent boundary. As plates continue to move apart, an uplifted ocean floor will develop in both sides of the plates, which is called oceanic ridge. Since oceanic crust is thinner than the continental crust, the creation of a liner-shaped lowland between oceanic ridges will develop called rift valleys. Now let us check your understanding. Go to page 13 of your module and answer what I have learned section of your module. You have 10 minutes to answer this. You did great! Magaling mga bata! This time, we will learn about the processes and landforms along transform fault boundary. Lesson 3 of your module. Transform plate boundaries are characterized by plates moving horizontally against each other, producing a crack called fault on the ground. The force the plates exert can break the rocks and other materials under the ground. Therefore, this is why it brings about strong earthquakes. Strong earthquakes do not only destroy properties, but it retains life as well. It is for this reason why we are taught on how to respond appropriately through earthquake drills. To test what you have learned from our lesson for today, answer the assessment pages 17 to 18 of your science module. You did well today mga bata. I am excited to see all your outputs. And that's end our lesson for today. But don't worry, more science adventures are coming on your way. Hanggang sa muli!